two thin wire rings each having a radius r are placed at a distance d apart with their axes coinciding. The charges on the two rings are plus q and minus q. The potential difference between the centers of the two rings. So before going to the problem, we'll see the ring. We have a ring. I'll keep the ring such that its plane is perpendicular to this board. It is having some charges. Let the charge be q. Uniformly distributed. Let the radius is r. Along the axis, we'll consider one point P. Say the distance is x, where we need to find a potential. For this, let me take a small length here called dl, and this dl having some charges, say dq, and a dq is equal to therefore lambda into length dl, where lambda is linear charge density. It is q divided by, it is 2 pi r into dl. Now this charge is available produce a potential at point P. So therefore let the potential is dV, that is 1 by 4 pi epsilon naught. It is a dq charge divided by distance, say it is a, that is 1 by 4 pi epsilon naught dq. It is a q divided by 2 pi r into dl divided by a. Since the potential is a scalar, the total potential is a summation of dq or dv, that is summation of all these factors, where 1 by 4 pi epsilon naught is a common, q is a constant taken out, 2 pi r and a common out. It's a summation of therefore dl, that is 1 by 4 pi epsilon naught. It is a q divided by 2 pi r into a. Summation of 2 pi dl is 2 pi r. So 2 pi r cancels. So remaining is 1 by 4 pi epsilon naught. It is a q divided by a. A can be written as, it is r square plus x square. So this is the potential along the axis of a ring which is uniformly charged. Now such rings are taken in this problem and they are placed at a distance of d apart. We'll continue. There are two rings now. So one ring is having a positive charge. It's a plus q. Is a ring number 1. Let me write. The second ring is here and it is having a charge minus q, and this is second ring. The separation between them is given to be d. Separation is d. We need to find out the potential at a as well as b. Then find a potential difference. The question is asked, potential difference between the centers of the two rings. You find a potential at a and potential at b. Find a difference. How to find a potential at a and b? If you find a potential at a, it is a potential because of the ring 1 and potential due to second ring. That means potential at a is equal to potential due to ring 1, its center, plus potential due to second ring at the center of 1. That is potential at center of the ring is given by, where x is equal to 0. If I put x is equal to 0, it's a q by r. That is 1 by 4 pi epsilon naught. It is a q divided by r, where r is a radius. Since the charge is positive, potential is positive. Now what is the potential due to second ring at the center of the first ring? It is charge negative, therefore potential negative. 1 by 4 pi epsilon naught. It is a q divided by distance is d. It's a square root of r square plus d square. The formula already we know. And this is a potential due to the two rings at the center of A, or center of first ring, that is at A. Similarly, potential due to the charges available two rings at the center B, and that is potential due to second ring alone plus potential due to at the center of 2 due to 1, and that is given by, it is minus 1 by 4 pi epsilon naught. It is a q divided by r. It's a negative charge, therefore minus. First ring is positive charge. Its potential is positive. It is 1 plus 1 by 4 pi epsilon naught. It's a q divided by square root of r square plus d square. When you consider potential A as well as potential B, we know along the axis the potential is less. Along the axis potential decreases. If you consider the potential A, it is a q by r is a positive, but second term is negative. Whereas B, potential B, second term positive, which is less value, and potential to the charge, negative charge is greater. Therefore, VB is less, VA is greater. Therefore, we find a potential difference VA minus VB, and that is a potential difference. And if you find a potential difference, we know first term minus or minus become plus. Therefore, it's a 2 times 1 by 4 pi epsilon naught. It's a q divided by r. Minus of this, minus of second term. Therefore, once again added, it is minus 2 into 1 by 4 pi epsilon naught. It is a q divided by square root of r square plus d square. Further, you can take 2 outside and 4 pi, q outside. It's a 4 pi epsilon once again taken out. Remaining is 1 by r minus 1 by square root of r square plus d square. And this is a common potential we have. We can solve further. It's a 2 can be cancelled. It's a 1 by 2 pi epsilon naught. Therefore, it is q divided by 1 by 2 pi epsilon naught into 1 by r minus 1 by root of r square plus d square in the denominator, and that is given as option B. Therefore, option B is right.